Hello, here's a quick little video to show the difference between a conventional EI transformer and the BiToroid transformer when they're placed on load. Right now we have our voltage sine wave in blue, the current sine wave is yellow. The purple sine wave is the power or the voltage across the load, and the red sine wave is the power. Now I want to show you what happens when the conventional transformer is placed on load using this light bulb. And okay, so now we're on load, and as you can see, I'm going to put it on to no load here. When the conventional transformer is placed on load, you will see the yellow sine wave, the current, shift, and you'll see the red sine wave increase, and the current in the primary also increases, and the red sine wave goes above the middle line, denoting that all of the power in the primary is real power, and the current shifts over towards the voltage sine wave, indicating that the power factor is shifting towards a power factor of 1. So that's conventional transformer operation, and rough numbers are the current increases by about double, and the power increases by about 300% in the primary. So now what I'm going to do is I'm going to switch over and put the bit on load here. Alright, so now we've engaged the bit, the BiToroid transformer, and I'm going to put it on no load here just to start with. So now the BiToroid transformer is on no load, and you can see the red sine wave is almost equal on top and bottom, which means that the power in the bit is mostly reactive. You can see that the voltage and the current are 90 degrees out of phase, virtually 90 degrees out of phase, again meaning that the current in the primary and the power in the primary is reactive current and reactive power. So now I'm going to put the bit on load. Pay attention to the current and pay attention to the power. The current in the primary increased from 21.6 milliamps to 21.7 milliamps. And the power increased by about 50%. That's due to about a 5-degree phase shift in the current. If you recall the conventional generator, the current shifted almost all the way over so that it was in phase with the voltage, and the current increased. In the bit, there is virtually no reaction between the phase shift and the current. And what this means is that if the bit was employed in an electric vehicle between the generator and the batteries, the generator would be able to supply reactive power to the primary of the bit, and the bit would supply real power to the battery. And the generator would operate as if it was under a no-load condition, because the current and voltage are 90 degrees out of phase, and essentially there would be no armature reaction in the generator, and essentially the generator would be able to supply extra power without the regenerative braking effects. Thank you for viewing. Cheers.